Hello everyone. In this video I'm going to show you how to find the intersection point of a line and a hyperplane. This can be done in any dimension, and let's see what is the question. Question says find the intersection point of the hyperplane given by this linear equation with the line given by this parallel point equation. So what you need to know to be able to solve questions like this, note that this can happen in any dimension, in R2, R3, Rn. And what we need to do is these steps. First, to find the intersection. First, write parametric equations for the line. So we need parametric equations. So find parametric equations for the line. Step 2, when you find parametric equations, for each x1, x2, x3, x4, for each component you have an equation, and each component is given in terms of t. Then you plug in those equations in the equation of the plane or hyperplane. So then plug parametric equations into the equation of the hyperplane. If you do that, then you will get an equation in terms of t. And equations in terms of t means solve that equation. So step 3 is solve the equation for t. You find value of t. When you find value of t, you go back to parametric equation and plug that value of t in the equations and find values of the intersection point. So the last step is plug the t that we found in step 3 into the parametric equations and find the intersection point. That's it. Plug in parametric equations in the equation of the hyperplane, solve for t, plug it back into the parametric equations, and you'll get the points. Okay, so let's do this steps, all the steps for this specific example. So note that the equation for the line given here is point parallel. We know how to go from point parallel to parametric equations. What you need to do, I need to write xt, x2t, x3t, x4t. Well, parametric equations are nothing but you just expand these things, write each component for the corresponding variables, or what you can do, this is the direction vector, this is the point. And we know that in the parametric equation, I have one t appearing in each equation. The coefficient of each t is the corresponding coefficient in the direction vector, meaning that the first variable x1 it will have the coefficient 2 for t. So 2 there. Second one will have 1 as the coefficient. The third one will have 1, and the fourth one will have 0. I'm not done. I have to add the corresponding components of the point to each equation. So the first equation will be 2t plus 3. The second equation will be t plus 1. The third equation, t plus 1. And the last one, negative 1. Well, OK, then let me just simplify this. x1t is 2t plus 3. x2t is t plus 1. x3t is t plus 1. x4t is negative 1. OK, so the first step is done. To find intersection point, I always need parametric equation. That's it. The first step is this. Second step is that step 2. This is step 1. Sometimes in the questions, the line is given in parametric equations form, which make our life easier. OK, let's do the second step. It says plug parametric equations into the equation of the hyperplane. What does it mean? I have x1 in terms of t written by this parametric equation, x2 in terms of t by this, x3 in terms of t by this, and x4 by this. Now plug in each one in this equation for the hyperplane. x1 is 2t plus 3, so I will have 2t plus 3, that's x1, plus x2 has parametric equation t plus 1, plus x3 minus 2 times x3, x3 is t plus 1, plus 3x4, so 3 times x4, the equation for x4 in the parametric equations is negative 1. And this should be equal to 3. OK, so let me just simplify this and write it right up there. So I have this equation. 2t plus negative 2t, and you add them. So 2t plus t is 3t minus 2 is t plus. I have 3 here, plus 1 is 4, negative 2 here. So 2 minus 1 is negative 1, is equal to 3. Again, I did a bit quick here, but what you need, just expand everything here, write all the coefficients of t together, write all the constants together, and you will get an equation for t. I'm done with step 2. Step 3 is solve this thing. So I have an equation in terms of t, solve that for t, meaning that keep all the variables one side, constants to the other side. So I'll take negative 1 to the other side, I'll get 4. That's the solution. That's t equal to 4. But that's the parameter of the intersection point. I have to find the point itself, meaning that I have to do step 4 by plugging in t equal to 4 in the parametric equation. I find the point. So the intersection, so step 4, the intersection point is x1 at 4, x2 at 4, x3 at 4, and x4 at 4. x1 at 4 is 2 times 8 plus 3 is 2 times 4 plus 3, so is 8 plus 3 is equal to 11. x2 at 4 is 4 plus 1, which is 5. x3 at 4 is 4 plus 1, which is 5. And x4 at 4 is negative 1. I found the point. The only thing I need to do, write them as four tuples. So the point is the first component is 11, the second component is 5, third component is 5, and the last component is negative 1. Very quick wrap up. To find intersection of a line and a hyperplane or a line and plane, what you need to do is to have first parametric equations for the line. Then plug parametric equations of the line into the equation of the hyperplane. You'll get an equation for t, solve that equation for t, find the value of the parameter in the intersection point. In this case, it was 4. And the last step is plugging back that parameter 4 into the parametric equations, and you will get the intersection point.